Mutually exclusive events. In a probability theory, two events are said to be mutually exclusive if they cannot occur at the same time or simultaneously. That is, any one of the two events are mutually exclusive means they will not occur together. That type of events are called mutually exclusive events. We can check one example. A clear example is the set of outcomes of a single coin toss, which can result in either head or tail but not both. We know the tossing a coin. That case we will get the outcome head or which outcome tail. That means that head or tail it will not come together. That type of events are called mutually exclusive events. So tossing one coin. This case we will get only one outcome, that is head or tail. That type of events are called mutually exclusive. That mutually exclusive means they cannot occur at the same time or simultaneously. Some examples for mutually exclusive events. Turning left and turning right are mutually exclusive. You cannot do both at the same time. That means you can't do the same time you can't do turning to left side and turning to right side. That means any one part you can do that at the same time. Turning left side or turning right side. We can't do these two together. That means these two events are called which one? Mutually exclusive. So another example, in a six-sided die, the events 2 and 5 are mutually exclusive. We cannot get both the events 2 and 5 at the same time when we throw one die. That is, we know in six-sided die case, if we throwing a six-sided die, that case the outcomes are 1, 2, the numbers 1, 2, 3, the outcomes are 6. That case any one outcome, that means is it possible to get the outcome together 2 and 5, these two or 2 and 5, these two events, is it possible, is it okay, will it occur together, that 2 and 5? It is not possible, because in that case we will get only one single outcome, 2 or which one, 5. That means these two or 5, that 2 and 5, that two outcomes will not occur together. That means these two events are called, the events 2 and the events 5 are called mutually exclusive events. That is, it is impossible to roll a 2 and a 5 together. The next, in a six-sided die, the events rolling a number divisible by 2 or rolling a number that is a multiple of 5 are mutually exclusive event. The same case here also, one six-sided die is there. In that case there are two events. First event is rolling a number divisible by 2. The second event is rolling a number that is multiple of 5. We can take that two events. The first event A is equal to, I took here the first event as A, that is A is equal to the rolling a number divisible by 2. We know the divisible by 2, the numbers 2, 4 and 6. These numbers are divisible by which one? Divisible by 2. That is the number, rolling a number divisible by 2. The numbers are 2, 4, 6. The next event, rolling a number that is a multiple of 5. That multiple of 5 case, we know the six-sided die case, the outcomes are the numbers from 1 to 6. That numbers, that 1 to 6, that number case, we know the multiple of 5. Which number is which numbers are multiples of 5? Only one number, that number is 5. We can take that event as B, that is B is equal to set 5. Only one single outcome, this case, at this event B case. Okay, then now you can check these two events. Will it occur together, these two events? These two events will not occur together, because this event A case the numbers are 2, 4, 6. The event B case the numbers are 5. Then we know these two events will not occur together. That means these two event case, there is no common number. That means these two sets are disjoint. That's why these two events are called mutually exclusive events. Then some examples of mutually non-exclusive events. The last part we learned mutually exclusive events examples. Here we are going to learn the examples of mutually non-exclusive event. Mutually non-exclusive event or not mutually exclusive event. That events are not mutually exclusive. That type of events are called mutually non-exclusive events. That is not that events are not mutually exclusive. Okay, then one example, turning left and scratching your head can happen at the same time, because we can do these two things together. The same time we can do these two things, turning left side and scratching your head. Is it possible? Yes, we can do these two things the same time. That means these events are not mutually exclusive, that is mutually non-exclusive events. The next example, in a six-sided die, the events rolling a number divisible by 2. One event is rolling a number divisible by 2. The other event rolling a number divisible by 3. We can write these two. Yeah, I'm going to write these two events are in a which one? The set form. First we can take this event as A. That is, set A is equal to the numbers divisible by rolling a number divisible by 2. That is, these are the numbers divisible by 2. 2, 4, 6. That is the event A. The next one we can take this event as event B. Okay, that is rolling a number divisible by 3. We can take it as event B. That is event that say B, set B is equal to rolling a number divisible by 3. These numbers are 3 and 6 are divisible by 3. Okay, that is, we can divide this number 3 divided by 3 is possible, 6 divided by 3 is possible. Okay, if you check the other number, 2 divided by 3, is it possible? No. Then 5 divided by 3, it is not possible. Then 1 divided by 3, it is not possible. That is, only two number case is possible, 3 and 6. Okay, that is, these are the two events that here given, these two events. Okay, then the A is equal to, that means we got A is equal to 2, 4, 6 and B is equal to 3 and 6. Then in this case, these two events case, you can check here the number 6 is common. These two sets, the number 6 is common here. That means suppose there's throwing a die. That case, your outcome, you got the outcome 6. That means if the outcome is 6, that means the result of that experiment, one particular experiment, that is a 6. In that case, that two events happen together. That means that event, that is result 6, means the rolling a number divisible by 2 happened there. The same time rolling a number divisible by which one? 3 also happened there. That means these two events happen at the same time. Why that two outcomes happened at the same time? Because the result is 6, because 6 is common to which one? These two events. That's why these two events are not mutually exclusive, that is mutually non-exclusive events. The next, in a six-sided die, the events rolling a prime number or rolling an even number. You can write these two events as a set form. That is, A is equal to rolling a prime number. The prime numbers are 2, 3, 5. The next, rolling an even number. Rolling an even numbers. The even numbers are 2, 4, 6. Okay. Then in this case, now you can check here 2 is common. That means the result, that result is, if the result is 2, that means these two outcome happen, that these two events happen same time. That means these two events are not mutually exclusive. That means these two events are mutually non-exclusive events. Then that part, the previous part we noted, if two events are mutually exclusive, that means that two events are which one? Disjoint. That means mutually exclusive events are disjoint. Then we can represent this one is a Venn diagram. By using Venn diagram, we can represent these two sets. Here now, here you can check this set A and the events A and B case. There is no overlapping. That means these two sets are which one? Disjoint sets. That case, to find the probability of A or B, that probability of getting A or B. Then in probability of getting A or B, we are writing that one as in a set form P of A union B. That is A or B means that is in set, what is that one? Is union. Okay, that is P of A union B is equal to P of A plus P of B. A union B means these two set together, that this part and this part. Then that A P of A union B is equal to P of A plus P of B. Then next one, mutually non-exclusive events are, the next one is a mutually non-exclusive events are not disjoint. That is at least one common outcome between them. Then the last part we got that clear picture, because some events case we learned that one, because that events mutually non-exclusive events are which one is not disjoint. Their case at least one common outcome we can see. Okay, then we can, that means that we can represent this set in a Venn diagram form. That Venn diagram form means this mutually exclusive case there is no overlapping, but here in this case common elements are there. If common elements are there means we can draw like this. This overlapping is there. Why overlapping is there? Because this part is common to which one? The set A and the set B is the common region. This, what is this common region? Which way we can represent in set form? Which way we can represent this common region? That is A intersection B. Now you can check this region. This region A intersection B. This region A intersection B is common to the set A, and the region is common to which one? The set B. Now we can find P of A or B, that is P of A union B. In P of A union B means this full part. The P of A union B means this full part. That case, first if you take P of A, that is this part P of A plus the next one is P of B. P of B means this part. But in this two case, P of A plus and P of B, that part P of A case we took this region. Then P of B case also we included this region. That means this region is A intersection B. A intersection B came there two times. That means we have to subtract that intersection B. One A intersection B we have to subtract from that sum P of A plus P of B. Then from that sum we have to subtract which one? A intersection B. One A intersection B we have to subtract. That means we can write that probability like this. Probability of A or B is equal to P of A union B is equal to P of A plus P of B minus P of A intersection B. Why we used this one minus P of A intersection B? Because in P of A case and P of B case also this A intersection B part came. Then we need only one A intersection B. That's why we subtracted one A intersection B, because these two case A intersection B came is total how many A intersection B's are there? Two A intersection B's are there, but we need only one A intersection B. That's why we subtracted one A intersection B from that two. Okay, that means we got the result like this: P of A plus P of B minus P of A intersection B. Okay, then in mutually exclusive, if the two events are mutually exclusive, then that case directly find the sum of that two, that is probability of A plus probability of B. Then if the events are not mutually exclusive, that is mutually non-exclusive events, that case to find the probability, which way we can find? Probability of A plus probability of B minus the probability of that common part, that is A intersection B. That is the formula. These are the two formulas to find which one the mutually exclusive, and how to find to find the probability of mutually exclusive event case. We are using this method. Then to find which case mutually non-exclusive case, we are using which one? This formula to find the probability. Okay. Then we can check some examples. This case I am going to explain two methods. Okay, which method is easy? You can use that method in your examination. A lottery box contains 20 lottery tickets numbered 1 to 20. That is, a lottery box contains 20 lottery tickets is numbered from 1 to 20. If a lottery ticket is drawn at random, what is the probability that the number drawn is a multiple of 3 or 7? Okay, there are here in this case we have to find the if a lottery ticket is drawn at random, what is the probability? We have to find the probability of which one the number drawn is a multiple of 3 or 7. Okay, then that means we can first I am going to take the here this multiple of 3 as a one event and multiple of 7 as a other event. Okay, drawn is a multiple of 3 or 7. Multiple of 3 as a one event and multiple of 7 is the another event. Okay, we can take A as multiple of 3 and B as multiple of 7 like this. Then first we can write the S. What is S? S means the sample space. What is mean by sample space? Sample space means set of all possible outcomes of that experiment. Okay. Is the experiment here we know the number from 1 to 20. The outcomes are, if you take one number from here, then we know that outcomes are from where to where 1 to 20. That means the numbers 1 to 20. That are the outcomes. If you write that outcome, all outcomes, set of all that all outcome in one set, that is set of all outcomes. That part is called sample space. We are representing that one as the letter S. That is all possible outcomes of that experiment. That is yes. Okay, then we can take this as a which one multiple of 3 as a one event, that is A. A is equal to multiple of 3, that is equal to what is that one multiple of 3 we know the multiple of 3s are 3, 6, 9, 12, 15, 18. Is it possible to take 21? It is not possible because we can't take 21 from here because the outcomes are the possible outcomes are 1 to 20. 21 is not possible. That means the multiple of 3 that event is which one? The numbers are 3 to which number? 18. Okay. The next one, the B. We can take B as a multiple of 7. The event B as multiple of 7 is equal to 7 by 40. 7 and which number will come? 7. Then which number will come? 7 multiple of 7. 7. The next 40. Okay, 7, then 2 times 7, 40. Then what is 3 times 7? That is 21. Is not in which one? This is not. It is not possible to take 21 from there because 21 is not a which one? The possible outcome. Okay, that's why we can't include 21. Okay, this set only which numbers we can include? 7 and 14. Okay, then what is the probability of getting A? The event A. Yeah, then probability case we know the probability of event A is equal to number of favorable outcomes divided by total number of outcomes. Then in this case, number of favorable probability of getting the event A is equal to number of favorable outcomes. How many favorable outcomes? How many outcomes are favorable to this event A? Here in this case, 1, 2, 3, 4, 5, 6 outcomes are favorable to which event? The event A. Then divided by total number of outcomes. Total how many outcomes are this one? These are the all possible outcomes. Total how many outcomes are there? 20 outcomes. That is 6 over 20. That is P of A. Then what is P of B? P of B is equal to number of outcomes favorable to B. How many outcomes are favorable to B? That is 2 outcomes. That is 2 over then total how many outcomes are there? That is number of outcomes. Total number of outcomes. How many outcomes are there? 20 outcomes. That means we can write 2 over 20. That is probability of B is equal to 2 over 20. Okay. Then the next first we can use here two methods we can find this answer. First I am going to direct method. One method, first one is direct method, that is direct way we can find the answer. The next one is the formula method. that last previous section we learned that formula P of A union B is equal to P of A plus P of B if it is mutually exclusive case P of A union B is equal to P of A plus P of B. If it is not mutually exclusive, that is mutually non-exclusive case, what is the formula? P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay, now but in this case now we can check first these two events, the event A and B. Is there any common number? These two cases there is no common number. That means these two events are mutually exclusive. That means any one thing happen at the same time. Say it's the same but particular, it will not this together, this the same time any one of the event will occur. That these two events the same time these two events is that possibility is not there because there is no common number. That means any one of the event will occur at the same time. Okay, that means event A or event B because there is no common number in these two events. That is, these two events are mutually exclusive. Then that case we can use the formula P of A union B is equal to P of A plus P of B. Okay, then that is the second method. Okay, then first method is the direct method, is the easy method also. Okay, that two methods I am going to explain here. First, direct method, that is in this case first we can find P of, that is the we have to number drawn is a multiple of 3 or 7, that is P of A or B. P of A or B means P of A union B we have to find here. Okay, then for that first we can find A union B. What is A union B? That is A or B means A union B. What is A union B? Here this A union B, that means combine these two set. We will get 3, 6, 9, 12, 15, 18. Then which one? 7, 14. That is A union B. Then we can find P of A union B. What is P of A union B? That is number of P of A union B is equal to number of outcomes favorable to A union B divided by total number of outcomes. How many outcomes are favorable to A union B? Here in this case 1, 2, 3, 4, 5, 6, 7, 8 outcomes are favorable to A union B. That means we can write it as like this, is equal to P of A union B is equal to 8 over 20. You know, total outcome, total number of outcome, how many outcomes are there? 20 outcomes are there. That is 8 over 20. Okay, that is the direct method, is the easiest one. Then directly we will get the answer. The next one is the formula method. That is, we know these two events are mutually exclusive. That is P of A union B is equal to P of A plus P of B. Okay, then what is P of A? P of A we found here 6 over 20. Then what is P of B? 2 over 20. We can write that part. That is 6 over 20 plus 2 over 20. Okay, the next one is simplify this part, that is 6 over 20 plus 2 over 20. We will get the answer 8 over 20. Now you can check these two methods, we got the answer 8 over 20. Here also 8 over 20. Here also we got the answer. What is the answer here? 8 over 20. Okay, here the answer 8 over 20. Here also answer 8 over 20. If you want, you can reduce again. That means we will get the answer 2 over 5. Here also 2 over 5. Okay, if you reduce, then we will get that answer. Okay, then next example. What is the probability that a die showing a number 3 or number 5? Here only one die case. First we can write set of all possible outcomes. Okay, set of all possible outcomes. Then how many outcomes are there in one die case? Only 6 outcomes. That is 1, 2, 3, 4, 5, 6. Okay, that is set. We denote that one as a yes because it's a sample space. Sample space means set of all possible outcomes of that experiment. Here throwing one die, one single die. That means the outcomes are 1, 2, 3, 4, 5, 6. Okay, then we can take the number A. A is which one? A is showing a number 3, that is A, and showing number 5 as a which one? The event B. That is A is equal to only one single number 3 and B is equal to only one single number 5. Okay, then we can find P of A. What is P of A? P of A is equal to only one number here. Then P of A is equal to 1 over. Then total how many outcomes are there? 6. 1 over 6. Then what of P of B? P of B means number of outcomes favorable to B. How many outcomes are favorable to B? Only one outcome is favorable to E. That is 1 over. The total how many outcomes are there? 6 outcomes. That means we can write 1 over 6. Then next, we are using first direct method, that is A or B. A or B means that is 3 or number 5, that is A union B. First we can find A union B. What is A union B? 3, 5. That means we will get like this. Then what is P of A union B? Probability of A union B is equal to number of outcomes favorable to A union B. How many outcomes are favorable to A union B? 3. 2 outcomes are favorable to A union B, that is 2 over total how many outcomes are there? 6. That means you will get the answer P of A union B is equal to 2 over 6. Okay, the next one is the formula method. Before using formula method, first you have to check this one is whether it is mutually exclusive or not. Okay, then first check the set A and set B. Is there any common number? There is no common number. That means these common elements, that means these two set A and set B are mutually exclusive. That means we can use this formula P of A union B is equal to P of A plus P of B. Then what is P of A? We know P of A is 1 by 1 over 6 and P of B 1 over 6. That is 1 over 6 plus 1 over 6. We will get the answer 2 over 6. If you want, you can reduce this part again. Now you can check here, the answer is 2 over 6. Here this method, direct method, what is the answer? 2 over 6. Both answers are same. Okay, if you want, you can reduce these answers. Okay, in that case you will get the answer 1/3. Here also 1/3. That is 1 over 3. In both cases you will get the same answer. Okay, then next problem. 3 coins are tossed at the same time. Find the probability of getting 2 heads or 3 tails. Here how many coins are there? 3 coins. 3 coins are tossed at the same time. Okay, find the probability of getting 2 heads or 3 tails. Okay, first we can write all possible outcomes, that is sample space S. S is equal to, that is, first one is all head, that is that 3 coins shows head, that is H H H. The next case I took like this, that is 2 coins show head and 1 coin shows which one? Tail. That is 2 head 1 tail. That is different way we can write that one, 2 head 1 tail. That is 2 head 1 tail. The meaning of this one is first 2 coins show head and the last one, the third one shows which one? Tail. Then here the first coin shows head, second coin shows tail, the third coin shows head. Then here first coin tail, head, head. Okay, the next one is 1 head. Now here this case we took 2 head case. Then here next take 1 head case, that is only first coin shows head, only second coin case shows head, only third coin shows head. That is the 3 cases. Okay, the next one is, now we completed, first one is 3 heads case we completed, that is this one. Then 2 heads case completed, that is this part. Then 1 head case we completed. Okay, the next one is no head. No head means all are which one? Tail, that is 3 tails. Okay, these are the outcomes of this experiment, that is 3 coin are tossed at the same time. That time we will get these results. Okay, these are the possible outcomes. Okay, then we wrote that one as a set ES. It's a sample space, like that way we took that one. Okay, then next we can take the 2 events, that is event A and B. Here find the probability of getting 2 heads or 3 tails. We can take A as probability of A as 2 heads and B as which one? 3 tails. That is A is equal to 2 heads. 2 heads means showing 2 heads. Okay, getting 2 heads. Then that means this case 2 heads, here 2 heads, here 2 heads. Okay, then here the next one is 3 tails. That is we took B as 3 tails case. That is this part 3 tails. Okay, there is only one outcome here. Here in this case, how many outcomes are there? 3 outcomes are there. Okay. Then what is probability of A? The number of outcomes favorable to A. How many outcomes are favorable to A? 3 outcomes. That is 3 over total number of outcomes. How many outcomes are there? 8 outcomes. Okay. Then P of B. How many outcomes favorable to B? Only one outcome. Then total number of outcomes. How many outcomes are there? Total number of outcomes? 8 outcomes. That is 1 over 8. Okay. Then first one, direct method. Direct method case, first to find A union B. A union B is equal to union of these two sets. Okay, that is, you will get like this. Okay, then P of A union B, number of outcomes favorable to A union B. How many outcomes are there? 4. Divide by which one? Total number of outcomes. How many outcomes are there? 8. Okay, that is, we got the answer 4 over 8. The next one is the formula method. Before using formula method, first you have to check this part is a whether it's a mutually exclusive or not. First you have to check that one, mutually exclusive part. Then this is set A and set B. Is there any common elements? These two sets, there is no common elements. Okay, that means these two sets are mutually exclusive. That means mutually exclusive case, if two sets are mutually exclusive case, then that case we can use the formula P of A union B is equal to P of A plus P of B. Then what is P of A? 3 over 8 plus P of B 1 over 8. That means we can write 3 over 8. 3 over 8, it is not 3, sorry, it is 3 over 8. 3 over 8 plus 1 over 8. Okay, 3 over 8 plus 1 over 8. 3 over 8 plus 1 over 8. We will get the answer 4 over 8. Okay, that is the answer. Now you can check this both case. We got here 4 over 8. Here also which one? 4 over 8. Okay, here this part here, it is not 3 over 3, it is 3 over 8, because P of A is, what is P of A? P of A is 3 over 8. Okay, that is here also P of A. What is P of A? P of A is 3 over 8, not 3 over 3. Okay, there is a one small mistake. Okay, 3 over 8 plus 1 over 8. We will get the answer 4 over 8. Okay, then now you can check this both method. We got the same answer. What is 4 over 8? 4 over 8 is 1 over 2. That is 1 that is half. Okay, equal chance. The next question, one ball is selected at random from a bag containing 3 red balls, 2 yellow balls, 2 white balls. That is, one ball is selected at random from a bag containing 3 red balls, 2 yellow balls, 2 white balls. Find the probability of selecting a red ball or a white ball. Okay, then this case, first one, what is the probability of getting a red ball? Here total how many balls are there? That bag contains, that is a bag. Yes, bag contains how many balls are there total? Total 3 plus 2 plus 2. Total 7 balls are there. That is, possible outcomes are 7. Okay, that is total number of outcomes 7. Then here in this case we need which one? Red ball. Then how many outcomes are favorable to red? How many outcomes are favorable to red? 3. That is 3 over total outcomes 7. That is 3 over 7. Okay, then what is probability of getting yellow ball? How many yellow balls are there? 2 yellow balls. That means probability of getting yellow ball 2 over 7. Then here how many white balls are there? 2 white balls. Then what is the probability of getting white ball? 2 over, then total number of outcomes. How many outcomes are there? 7. That is, probability of getting white is equal to 2 over 7. Okay, these are the probabilities. Then we have to find the probability of selecting a red ball or a white ball. Then first we are direct method. Okay, we are going to find the direct, by using the direct method we are going to find the answer. That is, find the probability of selecting a red ball or a white ball. Probability of getting red ball or a white ball. Red ball, or that is the number of favorable outcomes to red or white. How many outcomes are favorable to red or white? How many outcomes are there? That means if we get red ball or if we get which one? The white ball. Any one ball is okay. That means that how many outcomes are favorable to red or white? Total how many outcomes are there? 5 outcomes are favorable to this part. Okay, that is 5 over total number of outcome 7. That means we can write like this: probability of R union W, or R union W, or we can write R or W. Okay, R or W is equal to 5 over 7. Okay, that is the answer, because number of outcomes favorable to red ball or which one, white ball. That is, number of outcomes favorable to red ball or white ball means how many outcomes are there? 5 outcomes are there. That is 5 over total number of outcomes 7. Okay. Then next one is formula method. Then formula method, first you have to check here, is a mutually exclusive or mutually non-exclusive. Which type of event this one? Then now suppose that from bag, if you are taking one ball, then that case only one particular event will happen. That means it will not which one, this you will not get. If you take one ball from the one ball, you are taking one ball from there. That means this type of events is a which type of events? That is a mutually exclusive event. That means red ball or white ball, red or white. That means that two events will not happen together. You will get only one event, red ball or white ball, or which ball you will get. If you take one ball, yellow ball. Or if we in a red and white case, that is red or which one, white. Any one outcome will happen there. That means that two events will not happen. Okay, that is that it will not that two events will not come together, red and white, because when we are taking one, we are taking only one ball from there. That is one ball, that is a red or which one, white. Okay, that means that two outcomes are this type of case. That is, if the question is like this type, is always which one, mutually exclusive, because if you are taking one ball from there means we know that one, that particular result case, red and white, that situation will not come, or red ball or which one, white ball, that case only possible. That is, it will not come together. That is, that two events will not happen together. That means that two events are which one, that two events are mutually exclusive. That is, we can write P of R union W is equal to P of R plus P of W. Okay, then here in this case, what is P of R? P of R is 3 over 7 plus P of W. What is P of W? 2 over 7. That is 3 over 7 plus 2 over 7. You will get the answer 5 over 7. That is the, here you can check these both answer. Direct method case 5 over 7. This formula method case also, both case we got the same answer. Now we discussed around 3 or 4 problems. That 4 problems are which one? Mutually exclusive events. Then next we are going to learn non-mutually, that is not mutually, that events are not mutually exclusive, that is mutually non-exclusive event. We can learn one that type of problem. Okay. What is the probability that a die showing an odd number or a prime number? What is the probability that a die showing, here how many dice are there? Only one die. Okay, single die, showing an odd number or a prime number. First, we can write set of 4 possible outcomes. These are the possible outcomes. The next one, A is the odd number, 1, 3, 5. Then prime numbers, we know prime numbers are 2, 3, 5. Then P of A, what is probability of getting the event A? Number of favorable 3 over total 6. Then P of B is equal to, here total number of favorable outcomes 3 over which one, the total number of outcomes 6. Okay, 3 over 6. The next direct method case, first we have to find A union B. What is A union B? It's equal to 1, 2, 3, 5. A union B is equal to 1, 2, 3, 5 is the set A union B. Okay, then probability of A union B is equal to number of outcomes favorable to A union B. How many outcomes are favorable to A union B? That is 4 outcomes. That is 4 over the total number of outcomes. How many outcomes are there? 6. 4 over 6. Then another, now direct method, that part completed. The next we are going using formula method. Before using formula method, first you have to check this outcome. Say mutually exclusive, because mutually exclusive, mutually non-exclusive case, both case we are using different formula. That's why first you have to check the events are exclusive, mutually exclusive or not. First you can check these events A and B. These events A and B, here this case 3, number 3 is common. number 5 is also common. That is, we know if the two events are disjoint, then we can say that the two events are mutually exclusive. The two events are not disjoint means that two events are mutually non-exclusive events. In this case, two numbers are common. Okay, that is 3 common, 5 also common. If any one number is common, then that case we can say that two events are mutually non-exclusive. That means these two events are mutually non-exclusive. Okay, that means we have to use which formula we have to use here. P of A union B is equal to P of A plus P of B minus P of A intersection B. This formula we have to use here. Then here in this case, P of A union B is equal to P of A plus P of B minus P of A intersection B is the formula to find which one in mutually non-exclusive event case. We are using this formula to find P of A union B. Then here we don't know A intersection B part, P of A intersection B part. First we have to find this P of A intersection B part. Okay, first we can find A intersection B. Then here what is, we know A and B. What is A intersection B? A intersection B is the common elements, that is 3 and 5. Then what is probability of A intersection B? Probability of A intersection B is equal to then number of events, number of outcomes favorable to A intersection B divided by total number of outcomes. Here in this case, how many outcomes are favorable to A intersection B? 2 outcomes, that is 2 over total number of outcomes. How many outcomes are there? 6. That is P of A intersection B is equal to 2 over 6. Okay, that means then we can substitute this value. Now we know P of A, P of B and P of intersection B also we know. Then substitute that value here. That means P of A. What is P of A? 3 over 6. P of B 3 over 6. Then minus P of A intersection B, we will get 2 over 6. Okay, that means we will get the answer 2 over. If we simplify this expression, we will get the answer 2 over 6. Okay, then here 3 plus 3, 6, 6 minus 2, 4. That is, you get the answer 4 over 6. The same thing, 4 over 6. Then 2 is common. If you reduce that part, then we will get the answer 2 over 3. That means these two answers are same. Okay, then here why these two events are not mutually exclusive? Because here common elements are there. If common elements are there, means that two events are mutually non-exclusive. Okay, then that means if the two sets are disjoint, that is there is no intersection, that case we can say that two sets are mutually exclusive. Okay, if one element is common, that case it becomes which one? Mutually non-exclusive. Here in this case, two elements are common. That means these two events are which one? Mutually exclusive events, because common elements are there. Okay, then in that case we have to use which formula? This formula, P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay, then substitute all these values, then simplify, then we will get the answer 2 over 3. Thank you.